Can the sound of a rocket launch kill you? How loud does the sound have to be before you drop dead from it? With the exception of the Tsar bomba, the loudest man-made sound ever recorded came from the rocket that helped get man to the moon, NASA's 1967 Saturn V rocket. In this video, we will be exploring the sounds of space exploration and answering the question, can a rocket launch be loud enough to kill? At what decibel range does damage occur? Sounds in the range of 150 decibels or so, that's your average fighter jet, are enough to cause permanent damage to the inner ear, potentially causing them to rupture. Ouch! If you were a rocker in the 70s, you might have even been exposed to sounds just shy of that range, with heavy metal bands frequently playing gigs that nowadays would have led to many a lawsuit and noise complaint. So what about sound levels that are loud enough to be fatal? As it turns out, noises above 185 decibels are so powerful they could instigate one's final shuffle off this mortal coil due to the sheer eardrum rupturing, organ shuffling, heart-stopping power of the vibrations. What are decibels? Now, when it comes to space exploration, things can get pretty damn loud. So, how loud was the rocket that got Armstrong and Aldrin on the moon? It's estimated that the Saturn V rocket produced a whopping 203 decibels during takeoff. Theoretically enough to liquefy concrete nearby and set fields ablaze. This didn't happen, by the way, thankfully. A 36% increase in decibels from fighter jet to Saturn V might not seem like a huge difference, but decibels are mapped on a logarithmic scale. Etymologically speaking, the word decibel is constructed from deci, as in the Latin decimus, meaning tenth, and bell, referring to Alexander Graham Bell, the inventor of the telephone. A decibel, however, does not pertain to a tenth of Mr. Alexander Graham Bell. It is not a ratio of how many of Mr. Telephone's humeruses you could fit inside a certain space, as humorous as that might be. Oh, that was bad. But rather, it is the standard measurement unit in acoustics and is most commonly used for expressing sound pressure levels, or SPL. If you're not a math brain, tune out for the next 10 or 15 seconds. The logarithmic aspect to decibels makes them rather unique. They differ from other units such as hertz because a decibel is a ratio between two values, expressed as 10x the log of the ratio of the powers. The decibel value, therefore, is based on the ratio of two power levels, P1 and P0. It might seem complex, but we can understand it better with an analogy. Okay, no more advanced math equations. Now, imagine an earthquake scale where each step up in intensity represents a 1-point increase on the Richter scale. But here's the catch. The actual energy released jumps by a much larger factor, say 32 times stronger for each step. This is similar to decibels. A small change in decibels, say 1 or 2 decibels, can represent a much bigger change in power, for instance, doubling or tripling the power. The decibel scale compresses large changes in power into smaller numbers. So, what does that mean in terms of NASA's Saturn V rocket? Like we said earlier, a 36% decibel difference between a fighter jet and Saturn V doesn't sound that much, but in reality, the Saturn V blasting off was 10,000 times louder than your average commercial jet engine. So it sounded like, well, a hell of a lot. Enough sound that you probably wouldn't be hearing anymore, or breathing either if you were close by. The sound-suppressing features of the Saturn V rocket. In order to protect people from the ridiculously loud vibrations emitted from the Saturn V rocket taking off, NASA turned to various means of sound suppression. It wasn't getting the entire space agency to stand nearby and shh at the craft if that's what you're thinking. The Saturn V was designed with an accompanying water suppression system that sprayed water on the launch pad to prevent damage. However, it wasn't fully used for the rocket's initial launch, which resulted in the collapse of CBS's news trailer 3 miles away from the press site. Following the CBS trailer hiccup, NASA worked on improving their sound suppression system. By the time the Space Shuttle program was in full swing, the launch pad's sound suppressing technology had been perfected. 6 huge water towers known as rainbirds that can hold, wait for it, 1.1 million liters of water are stationed at the launching pads, which release a biblical flood across the launch pad 7 seconds before a rocket launches. In a mere 41 seconds, all 1.1 million liters of water have escaped from the towers, and it is quite the sight to behold. So, how do these tricky rainbirds work to take the edge off? Bubbles of air in the water serve to absorb the sound waves. Much like how if you yelled underwater, it wouldn't be as crystal clear and loud as if you shouted to your friend above the water's surface. In addition to this controlled tsunami of sorts, large nylon water bags are positioned underneath a space shuttle rocket to reduce sound waves even further. These preventative measures take the sound levels from that of the Saturn V to the equivalent decibel of a fighter jet. Nice! So, could you die from the vibrations caused by a rocket launch? Absolutely. Thankfully, protective measures are put in place to protect people from the extreme sound energy produced. NASA also ensured that people weren't too close to the rocket, recommending a safe distance from the explosion to prevent injury. If you were standing about 65 feet from the rocket nozzle, the force would be equivalent to 1 ton of TNT detonating 150 feet away. The wind force would also be over 100 miles per hour, and the air would be extremely hot from the sound pressure. Forget about infinity and beyond, you would be departing from this life just like Saturn V departed from the launch pad. So, how would you die if you were too close to Saturn V? Standing under a blasting rocket launch louder than any other? Not a great idea, my friend. It would be like trying to chill under a barbecue while someone throws flaming gasoline on you for fun. The sound vibrations wouldn't be the thing that kills you first. Instead, it would be the flames shooting out from underneath the rocket. Obviously. First, the pre-burn. Imagine a giant blowtorch igniting inside the rocket. Standing there, you'd be crispier than a Thanksgiving turkey in seconds. Then, things get spicy. Literally. A hypergolic fuel mix gets ignited, basically a flamethrower aimed straight at your shoes, not looking good. Finally, main stage hits. The engines roar to life, spewing fire at supersonic speeds. You wouldn't just be cooked, you'd be launched like a confetti popper in 2 different directions, like a piñata at a quinceañera. Oh, and security might be a tad concerned about a tourist under a multi-million-dollar rocket. You'd have a better chance of sneaking into Area 51 than getting close to a live Saturn V. So yes, skip the Saturn V sunbathing. Trust me, there are better ways to get a tan. How close were people to Saturn V? Was there anyone close enough to get a little toasty, you ask? For the Saturn V launch, 3 men were approximately 360 feet away from the exhaust, which was pretty ridiculous, risky, and no doubt absolutely roasting, but alas, they survived, ears and all. The primary astronaut fire rescue team were positioned within 1,200 to 2,400 feet in most, if not all, cases during the Apollo missions, whilst the keen observers of Saturn V were positioned 3.5 miles away from the pad to ensure their safety. One of the onlookers reported, "It's like continuous thunder, and when you think it can't get any louder, it does. I remember the vibrations seeming to pass into my bones. The bird rises, the flames spew, and the thunder continues, rising in pitch as it climbs, finally dissipating into a sound like a billion sheets of heavy paper being torn lengthwise for a whole minute." That sounds like some sort of ASMR video gone horribly wrong. Risky adventures. Whilst no one has reportedly died due to death via rocket vibration, there is one cautionary tale to share. In 1955, the USA built an experimental turbo propeller nicknamed Thunder Screech. It was a test to see if a supersonic propeller was feasible. Reports of seizures and sickness in anyone who was remotely near it were numerous, and a few people even got knocked unconscious. With a name like that, it was hardly a surprise. Deathly rockets. In sum, if you cozied up to the Saturn V on November 9th in 1967, you would have most likely exploded from a mix of ferocious flames and intense vibrations. So, if you live near a launch pad, perhaps don't schedule a run or a picnic too close to the launch site unless you fancy staging the Last Supper. Plus, it would be pretty hard to get past an aerospace agency's security personnel. From rocket roars to rubber rooms to other salient stories about the stars, Astronomy Revelations have the astrophiles' backs, preferably located at least 3.5 miles from Launchpad 39. Click the subscribe button to keep a finger on the pulse and the pulsars. Don't touch one of those, you'd get fried too.